A great deal of research is focused on the amount of global warming resulting from increased greenhouse gas concentrations, but there's been relatively little study of the pace of the change following these increases. A new study concludes that about half of the warming occurs within the first 10 years after an instantaneous step increase in atmospheric CO2 concentration, but about 1/4 of the warming occurs more than a century after the step increase. The study was the result of an unusual collaboration of a climate scientist, Ken Caldeira, who contributed to the recently published Intergovernmental Panel on Climate Change report, and Nathan Myhrvold, the founder and CEO of a technology corporation, Intellectual Ventures LLC. The study brings together results from the majority of the world's leading climate models. Caldeira and Myhrvold analyzed more than 50 climate simulations, which were performed using 20 different climate models for the Climate Model Intercomparison Project Phase 5. They found a fairly high degree of consensus on the general character of the pace of climate change. In response to an instantaneous increase in greenhouse gas emissions, climate change is fast out of the starting gate, but then slows down and takes a long time to approach the finish line. There's substantial quantitative disagreement among climate models, however. For example, one model reaches 38% of the maximum warming in the first decade after a step increase in CO2 concentration, while another model reaches 61% of the maximum warming in this time period. Similarly, one model reaches only 60% of maximum warming in the first century after the step increase, while another achieves 86% of maximum warming during this interval. There's also substantial uncertainty in the ultimate amount of warming that would result from any given increase in atmospheric CO2 content. The most sensitive model predicts more than twice as much warming as the least sensitive model. Uncertainty in the amount of warming combines with uncertainty in the pace of warming. From an instantaneous doubling of atmospheric CO2 content from the pre-industrial base level, some models would project 2 degrees centigrade or 3.6 degrees Fahrenheit of global warming in less than a decade, while others would project that it would take more than a century to achieve that much warming. While there's substantial uncertainty in both the pace of change and the ultimate amounts of warming following an increase in greenhouse gas concentration, there's little uncertainty in the basic outlook. If we continue increasing atmospheric CO2 concentrations with emissions from the burning of coal, oil, and gas, the Earth will continue to get hotter. If we want the Earth to stop getting hotter, we have to stop CO2 emissions. The work is published in Environmental Research Letters. With the independence for nimble pursuit, Carnegie scientists tackle some of the most profound challenges in modern science, fundamentally changing what's possible for us, our planet, and our universe.